Hypothetical situation. You are tasked with researching this psychic monkey in the jungle somewhere. And so you got your little tranquilizer gun, and you're sitting at the top of the cliff, and here's your psychic monkey in a tree. But you know this monkey is psychic and will sense the minute you pull the trigger and will drop onto the nice, soft, fluffy bed. If you want to hit him with a tranquilizer dart, should you aim at the monkey, above the monkey, or below the monkey? Take a second, make your guess. The answer is you should actually fire at the monkey, because even though bullets move pretty fast sideways, they're still affected by gravity in exactly the same way as the monkey is. So they will fall at the same rate. So by the time the monkey is dropped a meter, so has the bullet. So by aiming directly at it, at some point they will collide. Trick with this and the last video that should be in the Google Classroom that you should watch, the Shoot and Drop by Harvard. It's supposed to show you that no matter what the horizontal velocity, that has zero effect on any vertical variables. Horizontal kinematics information has no effect on vertical. So vertical doesn't affect horizontal, horizontal doesn't affect vertical. So regardless of your initial horizontal velocity, that will have no effect on how it falls vertically, unless it's like shaped like a wing or something. But we won't go into that too much. Don't need to get into lift. So here is your like standard gist and how I kind of want you to write stuff. First of all, I would recommend you decide that down is positive and up is negative. Now, of course, you don't have to do that, but it just means everything will be positive. Because for straight horizontal projectile motion, everything will be in the downward direction. The object will fall down, acceleration is down, all that goodness. Now, here are things that will always be true if you're firing something directly horizontal off some high place. Vertically, your initial velocity will be 0 because you're just firing it horizontally. Horizontally, your initial velocity is equal to your final velocity. It's just constant because there's no side gravity, there's no sideways force changing your velocity. Vertically, there's an acceleration of 9.8 if you're on Earth. Horizontally, again, no side gravity, no force sideways. We're ignoring air resistance, which at lower speeds is fully reasonable, assuming you're not throwing something super not dense and not aerodynamic. And this will be the height fallen. Your vertical displacement is the height fallen. And your horizontal displacement is often called your range, how far from the edge something ends up, edge of the cliff. You will, in general, for these type of questions, just for horizontal projectile motion, always be using this formula. You're used to this formula, same thing. But if you notice, like our horizontal projectile motion scenario, we've always got one important 0. So vertically, VI is 0. So this whole term will go to 0. And vertically, your equation looks like this. D equals 1/2 AT squared, since VI is 0, which can be rearranged into this version. Horizontally, A is 0, so there's no sideways acceleration. So this whole term goes to 0. And horizontally, this ends up being your formula. So just separate formulas for both your vertical situation and horizontal situation. Never mix them, because again, like a vertical acceleration of 9.8 meters per second squared has 0 effect on any specifically horizontal variable. The one thing that can go between vertical and horizontal is time. It is not directional, and it is the same time to follow the path, whether you're looking at it vertically or horizontally. So oftentimes, your goal will be to take whichever one of these columns you have the most information about, use that information with this formula in one of these two forms to solve for t, and then take t, put it onto the other side, and use it to solve for your final answer. And that's basically how you do all of them. Here's a typical question. Find time with, this is just what I said. Your two steps, usually they're two-step problems. You find time with either your vertical or horizontal information, whatever you know more about, and then find the final answer using time. So here's an example question. We're firing something horizontally at 10 meters per second off a 19.6 meter cliff, and we're interested in the range. So the first thing we're going to do is we're going to create a table like this. Vertically, our VI is always 0, and our acceleration is always 9.8. Horizontally, our acceleration is always 0. So we can fill these in right away. We know our horizontal velocity, which isn't going to change. It'll stay constant because no side acceleration. And we know our vertical displacement. So the one thing we know the most about is our vertical information. So odds are, and yes, for this specific case, we will take our vertical information, applying it to this formula, use it to solve for time. We find it's going to be in the air for 2 seconds before it hits the ground. Using this formula, once we got that time, we can go put it into use it with our horizontal information, and use it to solve for horizontal displacement, which is our range. So it's going 10 meters per second, and it's in the air for 2 seconds before it hits the ground, so it'll go 20 meters. And that is how you do horizontal projectile motion. I hope that helped. Thanks for listening.